The year was 2025, and humanity stood at the precipice of an extraordinary transformation. Decades of technological progress had propelled society towards an unparalleled moment in history, where the dream of becoming a Type 3 civilization was no longer confined to the realms of science fiction. Yet, as we gazed into the vast cosmic horizon, the question remained: could we truly harness the energy of an entire galaxy, or were we doomed to falter before the enormity of such a task? The pursuit of a Type 3 civilization, as defined by the Kardashev scale, was an endeavor requiring boundless innovation, collaboration, and vision. It meant reaching beyond planetary confines, beyond even our solar system, and exerting control over the forces of an entire galaxy. The stakes were monumental, and the obstacles equally so. The technological leap. By 2025, artificial intelligence had reached unprecedented heights, streamlining research and expediting scientific discoveries that would have once taken decades. Quantum computing enabled simulations of entire planetary ecosystems, allowing scientists to perfect terraforming techniques and resource management strategies. Nanotechnology had revolutionized material science, enabling the construction of Dyson swarms, massive arrays of solar-collecting satellites designed to absorb the sun's energy at an astonishing rate. Yet, the dream of constructing a Dyson sphere, one capable of encompassing an entire star, remained elusive. The necessary materials, the sheer scale of engineering, and the ability to sustain such a structure presented enormous logistical challenges. Moreover, despite advances in nuclear fusion and antimatter containment, the exponential energy needs of a Type 3 civilization demanded solutions beyond current human understanding: energy and resource management. One of the greatest challenges was the transition from a fossil fuel-dependent society to one that could effectively harness cosmic-scale energy. Although renewables like solar and wind had become dominant on Earth, they paled in comparison to the energy requirements of interstellar expansion. Researchers speculated on the feasibility of harnessing black holes as power sources, extracting energy from their immense gravitational fields through theoretical structures known as Penrose spheres. Others explored the potential of controlled matter-antimatter reactions, a power source that, if mastered, could provide virtually limitless energy. Resource management was equally critical. Mining asteroids had become a reality, providing raw materials such as rare metals and water for off-world colonies. Space-based manufacturing had reached new heights, with automated factories on the Moon and Mars, producing spacecraft and scientific instruments at an unprecedented scale. However, despite these advances, humanity had yet to achieve the efficiency and scale necessary for interstellar operations. The challenge of galactic coordination. Even if technological hurdles were overcome, one undeniable barrier remained: humanity itself. The transition from a planetary civilization to a galactic one required a level of cooperation never before seen. National borders and geopolitical rivalries had long stifled progress, and despite movements toward a unified Earth government, tensions remained. Would humanity be able to put aside centuries of conflict in pursuit of a common goal? Could global leaders relinquish sovereignty for the sake of interstellar unity? The answer was unclear. Some believed that the existential threat of planetary limitations would drive cooperation, much like climate change had necessitated global efforts to combat its effects. Others feared that competition for space-based resources would ignite new conflicts, potentially dooming humanity before it could even begin its galactic journey. The role of artificial intelligence. In many ways, AI had become both the architect and guardian of our cosmic aspirations. Advanced machine learning systems had predicted and preemptively resolved supply chain disruptions, optimized space travel routes, and even played a role in governance. Some radical thinkers suggested that AI itself could one day serve as the governing entity of a galactic civilization and omniscient force, ensuring rational decision-making and eliminating human inefficiencies. However, such ideas were met with resistance. Could humanity truly entrust its destiny to machines? Would an AI-driven civilization still be a human civilization? Ethical concerns surrounding AI's role in governance remained a contentious debate, though its necessity in the pursuit of Type 3 status was undeniable. The first steps beyond the solar system. Despite the challenges, humanity had already begun taking its first steps beyond the cradle of Earth. The construction of an interstellar probe, equipped with revolutionary propulsion systems, was underway. Utilizing both laser-accelerated light sails and prototype Alcubierre warp drives, the probe was expected to reach Proxima Centauri within decades, a testament to our accelerating progress. Meanwhile, advancements in genetic engineering allowed for the adaptation of humans to extraterrestrial environments. Scientists had successfully introduced minor modifications that improved radiation resistance and muscle retention in microgravity, paving the way for permanent human settlement beyond Earth. Science fiction as inspiration. The dream of a Type 3 civilization had long been the domain of science fiction. From the intergalactic empires of Star Wars to the utopian visions of Star Trek, humanity had always imagined itself among the stars. Now, reality was beginning to catch up. These stories had inspired generations of scientists, engineers, and dreamers to push the boundaries of what was possible. Yet, for all our progress, the realization of a Type 3 civilization remained distant. While our technological leaps were remarkable, the sheer scale of the undertaking meant that we were still centuries, perhaps millennia, away from true galactic dominance. Conclusion: the road ahead. So, would humanity achieve Type 3 civilization status by 2025? The answer was a resounding not yet. But while the goal was far from reach, the foundations were being laid. Every breakthrough in AI, energy, and space travel brought us closer to a future where the stars were no longer out of reach. Perhaps the true significance of 2025 was not in reaching Type 3 status, but in proving that it was, indeed, possible. It marked the dawn of an era where humanity no longer saw itself as bound to Earth, but as a species destined to explore, innovate, and thrive among the stars. The journey had begun, and the universe awaited.
Thanks for watching. If you enjoyed this video, please like and subscribe.